Welcome to MarkScheme, the quadratic function. Everything you need made visual. Throw a ball, watch its path. It rises, curves over, and falls in one smooth, perfectly symmetric arc. That arc has a name. It's a parabola. And it is everywhere. The cable of a bridge, the jet of a fountain, the beam of a satellite dish. Now here's the twist. This whole video is about. That single shape can be written three completely different ways. General form, factored form, and vertex form. They look nothing alike, yet each one describes the exact same parabola, and each hands you a different secret about it for free. One shape, three disguises. Learn to switch between them, and quadratics become easy marks. Here's exactly what this covers, straight from your syllabus. IB analysis and approaches. Standard level 2.6. The general form, ax²+bx+c, where you read off the y-intercept and the axis of symmetry. The factored form, where the x-intercepts fall out. The vertex form, which gives you the turning point. And completing the square, the tool that turns the general form into the vertex form. This sits on top of graphs and key features from 2.4 and basic algebra from 1.1. If the words intercept or vertex are new, watch those first. Start with the form you'll meet most, the general form, ax²+bx+c. The three numbers a, b, and c aren't just clutter. Each one controls the graph. The leading coefficient, a, sets the shape. If a is positive, the parabola opens upward, a smile. If a is negative, it opens downward, a frown. The constant c is the easiest of all. Put x equal to 0, and every other term vanishes, leaving f of 0 equals c. So c is exactly the y-intercept. The graph cuts the vertical axis at 0, c. And the middle term b, together with a, fixes the axis of symmetry, the vertical mirror line down the middle of the parabola. X equals minus b over 2a. Memorize that one. Minus b over 2a. It locates the turning point in a single line, and will prove exactly where it comes from very soon. Second disguise, the factored form, a times x minus b times x minus q. This one is built for roots. A product is 0 exactly when one of its factors is 0. So f of x is 0 when x equals p, or x equals q, and nowhere else. Those two values, p and q, are precisely the x-intercepts. The points p, 0, and q, 0, where the curve crosses the horizontal axis. So if a quadratic is already factored, you can read its roots off by eye. No work at all. And there's a bonus. A parabola is symmetric, so its axis of symmetry sits exactly halfway between the two roots, at x equals p plus q over 2. That midpoint will lead us straight to the vertex. Third disguise, and the one examiners love to ask for, the vertex form, a times x minus h all squared plus k. Here's why it's special. A square is never negative, so a times x minus h squared is smallest. It's 0, exactly when x equals h. At that moment, f equals k. So the lowest point of the whole curve sits at hk. That point, hk, is the vertex, the turning point, and the form just reads it straight off. If a is positive, the parabola opens up, so the vertex is the bottom, and k is the minimum value of the function. If a is negative, it opens down. The vertex is the top, and k is the maximum value. And since the curve turns there, The axis of symmetry is simply x equals h. Watch the one sign trap now. The bracket is x minus h, so x minus 2 gives h equals plus 2. The sign flips. We'll hammer that later. Now let me show you why the vertex form is worth loving. Watch the vertex, the green dot, and the two numbers, h and k on the left. I'm going to change nothing but those two, and the entire parabola will obey. Increase h and the whole curve slides to the right. Drop k and it sinks downward. The parabola never changes shape. It's the same curve, just relocated, and the vertex goes wherever we send h and k. H shifts it left and right. K shifts it up and down. The vertex form is really just a set of coordinates for the turning point. And look at the gold trail. As we glide the vertex around, it traces out its own path, its locus. Every position the turning point visits is a value of hk. So reading a vertex, or moving one, is nothing more than reading, or moving a single point. That is the power the vertex form hands you, which is exactly why the next thing we learn is how to force any quadratic into it. Completing the square sounds like jargon, but it is a picture. And once you see the picture, it never leaves you. Take x squared plus 6x. Read it as areas. X squared is a square with side x, and 6x is a rectangle, 6 wide and x tall. Here's the trick that names the whole method. Slice that 6x rectangle down the middle into two equal strips, each 3 wide. Glue one strip onto the right of the square and swing the other up onto the top. We've split the 6 into two 3s. And notice, 3 is 6 over 2, half of b. That halving is the heart of it. Now those three pieces almost form one big square of side x plus 3. But there's a little square hole in the corner, 3 by 3, area 9. So the pieces we actually have, x squared plus 6x, equal the full big square, x plus 3 all squared, minus that missing 9. There it is, x squared plus 6, x equals x plus 3 squared minus 9. We completed the square and then subtracted the bit we added. And that picture is a formula in disguise. For any x squared plus bx, the answer is x plus b over 2, all squared, minus b over 2 squared. In words, have the middle number, square it, and subtract it back to stay balanced. Whatever's left after the constant becomes k. And just like that, you're in vertex form. Let's make the big idea unmistakable. Here's one fixed parabola. It will not move for the rest of this beat. Written the general way, it's x squared minus 2x minus 3. And from that, we read the y-intercept, 0 minus 3, straight off the constant. Now factor it. The very same expression is x plus 1 times x minus 3. Nothing about the curve changed, only how we wrote it. And in this disguise, the roots jump out. Minus 1 and 3, the two x-intercepts, and complete the square, exactly as we just learned. X minus 1, all squared, minus 4. Still the identical curve, but now the vertex is handed to us. 1 minus 4. 3 faces, 1 parabola. The whole skill of this topic is choosing the face that answers the question and switching to it. So before any calculation, ask one question. What does this problem actually want? That tells you which form to reach for. If it asks for the roots or the x-intercepts, get it into factored form. The roots are p and q, sitting right there. If it asks for the vertex, the turning point, or a maximum or minimum value, get it into vertex form. That's HK on a plate. And if you just want the y-intercept, the general form already gives it. It's C. Match the form to the job, and half the work disappears before you even start. Time for a ladder of examples. Easy to hard, all my own numbers. Example 1. Read the key features of f of x equals x squared minus 6x plus 5. First, the freebie, the y-intercept. Set x to 0, and only the constant survives. So it's 0, 5. Next, the axis of symmetry using minus b over 2a. Here a is 1, and b is minus 6. So it's minus 6 over 2. That's 3. The mirror line is x equals 3. Now the roots. This factorizes to x minus 1 times x minus 5. Because 1 and 5 multiply to give plus 5 and add to give 6. So the curve cuts the x-axis at x equals 1 and x equals 5. And notice 3 sits exactly halfway between them, confirming the axis. Every feature straight off the page. Example 2 takes that same quadratic and completes the square. To get the vertex exactly, f of x equals x squared minus 6 x plus 5. Focus on the x squared and x terms first, and apply the rule. Halve the middle number. Halve minus 6 to get minus 3, and square it to get 9. So x squared minus 6x is x minus 3, all squared, minus that 9 we introduced. Bring the plus 5 back down. X minus 3 squared minus 9 plus 5. Minus 9 plus 5 is minus 4. So the vertex form is x minus 3 squared minus 4. Read it straight off. The bracket is x minus 3. So h is plus 3. Watch that sign. And k is minus 4. The vertex is 3 minus 4. And because a is positive, the parabola opens up. So that vertex is the lowest point. The minimum value of the function is minus 4. Notice the axis. X equals 3. Matches example 1 perfectly. Same curve, different form. Example 3 adds the one wrinkle students trip on. A leading coefficient that isn't 1. F of x equals 2x squared minus 12x plus 5. The golden rule, and please don't skip it, is to factor the a out of the x terms first, before you complete the square. Take a 2 out of 2x squared minus 12x to get 2, bracket, x squared minus 6x, close bracket, plus 5. Leave the plus 5 outside. The 2 does not touch it. Inside the bracket, complete the square as normal. X squared minus 6. X is x minus 3 squared minus 9. Substitute that back in. 2 times the bracket x minus 3 squared minus 9 plus 5. Now expand the 2 across the bracket. And this is where marks vanish. The 2 multiplies the minus 9 as well, giving minus 18. Minus 18 plus 5 is minus 13. So f of x is 2, x minus 3 squared, minus 13, and the vertex is 3, minus 13. The a stays out front as the 2. It does not change h, but it absolutely scales the constant you pull out. Miss that and your k is wrong. Example 4 runs the machine in reverse, building a quadratic from its features, a real exam favorite. Find the quadratic with the roots minus 2 and 4, passing through the point 0, minus 8. Roots scream factored form. If the roots are minus 2 and 4, then f of x is a times x, plus 2 times x minus 4. Mind the signs. A root of minus 2 comes from the factor x plus 2, but roots alone don't pin down a. Infinitely many parabolas share those two x-intercepts, each a different width. That's what the extra point is for. Substitute x equals 0, f equals minus 8. Minus 8 equals a times 2 times minus 4, which is minus 8a. Divide. A equals 1. With the equal to 1, f of x is simply x plus 2 times x minus 4. Multiply it out for the general form. 2 times minus 4 is minus 8. And the middle term is minus 4, x plus 2x, which is minus 2x. So f of x equals x squared minus 2x minus 8. Roots. A point, done. And it threads exactly through 0, minus 8. Example 5 is the mirror image. They hand you the vertex instead of the roots. A parabola has vertex 1, minus 8, and passes through 3, 0. Find f of x. The word vertex points straight at vertex form. Vertex 1, minus 8 means h is 1, and k is minus 8. So f of x is a times x minus 1, all squared, minus 8, with a still unknown. Use the extra point to nail a. Substitute x equals 3, and f equals 0. 0 equals a times 3, minus 1 squared, minus 8. 3 minus 1 is 2, squared is 4. So 0 equals 4, a minus 8. Add 8, divide by 4. A equals 2. So f of x is 2. X minus 1 squared, minus 8. The vertex form, complete. Expand if a general form is wanted. 2x squared, minus 4, x minus 6. And as a free check, that factors as 2 times, x minus 3 times, x plus 1. Confirming a root at x equals 3. Exactly the point they gave us. 1 quadratic. And we can now write it in whichever of the 3 forms the question rewards. Now the exam craft other channels skip. The biggest time saver. You do not need to complete the square just to find the vertex. The x-coordinate of the vertex is always minus b over 2a. It comes straight from the axis of symmetry. So compute that. Then substitute it back into f to get the y-coordinate. 2 lines. Vertex found. 4 rules to bank. 1. For a vertex, use minus b over 2a. Then substitute. Fast and reliable. 2. Use the form the question hands you. If it's already in vertex form, read h and k off. If it's factored, read the roots off. Don't waste time expanding it back to general. 3. On paper 2, let the GDC do it. The minimum or maximum tool gives the vertex. The 0 tool gives the roots. Both to 3 significant figures. And 4, the one people forget. When a is in 1, factor it out of the x terms before completing the square inside the bracket. Finally, the 4 traps that quietly cost marks. 1. The sign of h. The vertex form is x minus h. So x minus 3 gives h equals plus 3, not minus 3. The vertex sits at a positive 3. Read the sign backwards, and your whole answer shifts to the wrong side. 2. Dropping the a when you complete the square with a leading coefficient. If you factor a 2 out, that 2 multiplies everything inside, including the minus 9, which becomes minus 18. Forget it, and your constant, your k, is wrong. 3. Confusing the vertex with the y-intercept. The y-intercept 0. C is where the curve meets the vertical axis, while the vertex h, k, is the turning point. They're only the same in the special case, h equals 0. And 4. Sign slips going from roots to factors. A root of minus 2 gives the factor x plus 2, not x minus 2. Dodge these 4 and quadratics become some of the safest marks on the paper. And that is SL 2.6, fully covered. The parabola in all 3 of its disguises. General form, where you read the y-intercept, and the axis of symmetry. Factored form, where the roots fall straight out. And vertex form, where the turning point is handed to you. Reached by completing the square. Next in the course, we solve quadratics for good and meet the discriminant. For more, that's markscheme.app. See you there.